As we already learned, everything in Linux is a file. So permissions for users in Linux system are related to the files. So basically each user in the system will have a set of permissions to access and execute different files. So let's look at files and permissions on those files to see how that works. You remember the ls command that we used to list files and folders in a directory, right? We also had ls-a flag that we add to ls command in order to display the hidden files and folders in addition. Well, we also have another flag here called l that shows us permissions of files and folders in that directory. So if I execute this, you see that the command displays a bunch of information on each file or folder in the directory, in addition to just displaying their names. And this additional information that you see here actually contain permissions on those files and folders. So let's go through this information one by one. First of all, when we're talking about users and their privileges or permissions, we have two concepts that we need to consider. The first one is a concept called ownership. The ownership basically means who owns the files or folders, or who has basically any permission at all for those files. And each file has two different owners. The first one is the user, and the second one is the group. So what you see here is the user owner of a file or folder, and the second one is the group as an owner of a file or a folder. And the owner of a file is usually the user that created that file. And the group, the owning group, is the primary group of that user. So for example, if I create a file here, let's just do text. Let's just create a text file. And if I do ls-l, you see the owner of this test.txt file is my user Nana, and group Nana. In this case, they're both called the same. So owner of the file is basically someone who has any permission or any access permission to that file. This could be a permission to just read the file, to just view the file, or it could be also to edit and delete the file. And even though the default owner of each file is the user that created that file and its primary group, we can actually change this information using a command called chown, right? So change ownership. And then we need the username who we want to give the ownership to. We have a user that we created called Tom. Let's say we want to make Tom the owner of that file, and the group should be admin. And then we have the name of the file, ownership of which we're changing. And if I execute this, first of all, this is a super user command, so we need sudo here, and right here you see that user and group owners for this specific file have changed. We can also see the owners of files in some of the root folders. So for example, let's see who is owning the files or folders in /etc folder, for example. And if we scroll all the way up, there are lots of folders and files here, and you see that most of them, with just a couple of exceptions, are owned by the root user and root group. Why? Because these are all system files that were created by the system itself, which is the root user. Again, going back to our folder, we can also change only the group owner or the user owner of a file. Very easy. Instead of specifying user:group, we just specify the user like this, and let's change it to admin user, for example. And if I display it again, there you go, we have admin user as an owner of this test.txt file now. And the same way we can change only the group here with another command, ch group. And we have a DevOps group here on our system, so we'll make DevOps group the owner of the test.txt file. And again, print out, and there you go. So this is how you can change permissions of a specific file or folder for a user owner and group owner. Now you're probably already wondering, sure, we have these owners as users or groups, but what is the point of this, or how does it actually define what permissions a user or group has on a file, right? So where are those permissions actually defined? Do I get read-only access as an owner, or do I get a write permission or edit permission? Can I remove the files or folders with this user or group, etc.? And those permissions are actually defined in another section, which is this one right here. So this block contains the permissions for each of the different owners. So basically, if Nana user is the owner of this folder, I can define what permissions that user has on that folder. And the same way, what permission does group DevOps has on this file. So let's look at this block now one by one. As a first character here, we have D or dash, which is actually very simple to understand. For directories, it shows D, that's basically the type of a file, because again, we said everything is file in a Linux system. However, these files have different types, right? Directory is, for example, one file type, and this type of a file is displayed right here. Right now, we just have a normal standard file, which is represented by dash, or we have a folder directory file type represented by D. Okay, so we know what the first character here stands for. That's the file type. And then we have permissions divided in three parts. The first part here, the first three characters that you see, RWX, actually represent permissions for the user who is the owner of that file. R stands for read permission. So the user, Nana, can see and access the contents of the file. Then we have W for write, which means I can edit the file. I can change the contents, I can write into it. So that's the write permission. And the third one is X for execute. And that is a permission to execute a file. Execute permission will allow a user or a group to actually run that script, to execute that script. Or if we have binary files for different programs or commands, for example, again, these are executable files. So X permission will give a user or group to execute that binary file. So this is one block of permission that applies to the user owner. Then we have a second block of permissions with exactly same permissions, read, write, execute. These are the only permission values basically you can have here. And this permission applies to the group owner of that file. Very easy concept. First block applies to the user, second block applies to group. And that means that with the combination of the owner of the file and the permission, you can see basically who has permission to do what on that file. For these three files, for example, you see that instead of X, we have a dash. And dash basically means that there is no execution permission on those files, right? So user Nana and group Nana doesn't have an execute permission on that file. Same goes for these other two files, right? So dash instead of the actual letter, instead of R, W, or X means that there is no read, write, or execute permission. Now we have a third block here that says R dash, which means no write permission, but an execute permission. So who does this third block actually belong to? Because we just have a user and group here. So what is the third block for? The third block actually belongs to the third owner of a file, which is everybody else. So all the other users who are not user Nana or who don't belong to the group called Nana. So everybody else who is not covered by these two is the third owner. And this owner is actually called other. For example, in this case, this will be user Tom, which is not part of a Nana group. This could be admin user, which is not part of a Nana group. So basically, we need permissions for all the other users on the system. And that's who this permission block here belongs to. That means everybody else who is not either this user or part of this group has a read permission on this folder as well as execute permission. And this is a default, so execute permission here doesn't make sense. This was assigned by default when we created the folder. However, for those three files, it actually looks pretty reasonable. We have read-write permission for the owner, the user who created the file, as well as the group. And for everybody else, for all the other users who exist on this system, the file is read-only. So they can't execute it or they can't edit it. So that's basically how permissions work. Again, combination of owner, which is the user, group, or other. That's the third owner, which you don't see here because it's always the rest of the users. And each one of those owners has their own specifically defined block of permissions. And of course, these are default permissions when you create a file, but you can change each one of those permission values. And let's actually do that. And let's remove the execute permission for this folder for all three owners. And here we have actually multiple different ways of changing permissions. One way to remove a permission, a specific permission, in this case execute permission from a file, is chmod, which is change mode. And then we do -x. So take away the execute permission for API folder. And let's display the results. And as you see, all those execute permissions for all the owners was removed. So as you saw, this removed permission for all the owners, but maybe we want to just change permissions for one specific owner. How do we do that? So for example, we want to take away the write permission for config.yaml file from the group. Again, sudo change mode. And we want to adjust permission of a group. And because of that, we type in G, that's for group, and we take away the write permission from a group. And we have to specify the file as well, of course, and execute. And now let's see, the group doesn't have a write permission anymore. Now, if you want to add a permission for a specific owner, in this case, let's add the execute permission to the group Nana for this file. Also very easy, we have group first of all, and instead of minus, so taking away the permission, we do plus, which adds a permission, and then we specify which permission that is going to be. And the file name, and there you go. And we can do the same for user. For example, we want to add an execute permission to the config.yaml. And let's take away the permission again for the group. Because again, as I said, the execute permission obviously makes sense for files that are executable. So what we're going to do is we're going to change the test.txt file to script.sh. So this is going to be the executable file. And let's say we write a script that starts the program, and that is something that you can run or execute on the system. And let's say we want to give the user admin permission to execute this file. For that, we're going to do U for user instead of G for group, and plus X for script.sh. And there you go, we have the result. And if we want to give that permission to other owners, then instead of U, we just type O for others. And there you go. So to wrap up, you can change permission of each specific owner by adding a permission or taking away a permission using U, G, or O symbols for user, group, and other, and then plus permission or minus permission. Or as we also saw, we can add the same permission or remove the same permission for all the users by either omitting the user symbol here or specifying A, which stands for all. And this will basically apply this change to all the owners. So that is one way of changing permissions for different owners. Another way of changing permissions is convenient when we want to change multiple permissions for one owner. So for example, for group Nana, we want to add write and execute permissions for config.yaml file. How do we do that? Again, we have G, and instead of specifying plus W and then plus X, we can do equals, and then we can write out the whole block of permissions like this. So we want that group to have read, write, exec, and the file name like this. And the same way we can specify a different permission where it only has read, write permission, or it has only write permission. So basically you can type out this whole block here as you wish, and this will set all three permissions for a group or user, for all other users, or for everyone on the system, and including the user and group owners. So that's a second way of changing multiple permissions for the owners. And the third way, which is also very common way of doing it, probably most common of these three options, is using numeric values. So right now we saw permissions with so-called symbolic values with letters. Now we're going to use numeric values. So how does it look like? Again, let's display our permissions, and let's say we want to set permission for all the owners in one value. We can do that by specifying a digit, a numeric value for each of those blocks. So we have 3 digits for each of the permission blocks for each owner. And these are the digits, and this is basically a mapping to the permission blocks. So all dashes, which means no permission, is number 0, and all the permissions, read, write, execute permission, is digit 7. So with these numbers, we can actually represent the whole block of permissions. So for example, if I want to give everyone on this file read, write, execute permission, I'm just going to do 777 and the file name. And let's see, there you go. And this is actually very convenient, as I said, to define permission blocks for all the owners and to define that with just 1 digit instead of typing out these read, write, X all the time. So for example, I want to give the owner, user, all the permissions, and I want to give the group only read permission, and I want to give everybody else 0, no permissions. That's going to be the number for that. And again, if we check, there you go. The user has all the permissions, group has only read permission, and other users have no permission. So you can use this table basically to set the values. And obviously you don't have to memorize this by heart, but if you use that enough times, that you will remember which value stands for what. So these are 3 ways of setting permissions for different owners. The first one is using symbolic mode by adding or removing individual permissions for each owner. The second one was just overriding the whole permission block also with symbolic values. And the third one is using numeric values to define permission blocks for all the owners in one command. And as I said, it may seem a little bit complex at the beginning, but once you understand how this all works, it actually makes sense and it's easy to use. You may choose just one of those options and just stick to it for all your use cases. And finally, if you didn't already notice, we don't have a hidden file or hidden folders here on the display, here with ls-l command. What if we want to see and change permissions for hidden files as well? Very easy actually. We do ls-l and we add this a option here as well. And if I execute, you see the long output with -l with permissions and stuff for hidden files as well. And exactly the same way, you can change permissions for the hidden files and folders just like you would for regular files.